In the constellation Orion, a star has long fascinated astronomers. Betelgeuse. This massive red supergiant, much larger and more massive than our Sun, has recently exhibited peculiar behavior, prompting speculation about its cosmic future. Betelgeuse has dimmed significantly and begun vibrating violently, leading some to believe it is nearing a spectacular supernova explosion. However, what if these changes signal something more ominous, a potential collapse rather than an explosion? Let's delve into the latest research on Betelgeuse and explore the profound implications its fate might have for the universe. A stellar giant. Betelgeuse is a colossus, approximately 1,000 times larger than the Sun and one of the largest stars known. Yet, its immense size comes at a cost. Stars like Betelgeuse have relatively short lifespans. Located roughly 650 light-years away, it shines brightly as one of the closest stars visible to Earth. Though its brilliance captivates us, only about 13.3% of its light is visible to the naked eye. If we could perceive its full intensity, Betelgeuse would outshine even Sirius in the night sky. Cosmic life cycle. Imagine a star so vast that its radius extends well beyond the asteroid belt, nearly touching Jupiter. If placed in our solar system, Earth, Mars, Mercury, and Venus would be engulfed by its gravitational pull. Every few thousand years, Betelgeuse sheds a solar mass, ejecting its outer layers in a spectacular celestial display. This process creates a cloud of material, sometimes 30 light-years across, enveloping the star in a glowing haze that invites astronomers to uncover its secrets. At its core, hydrogen undergoes nuclear fusion, producing helium and radiating immense energy. Over time, as hydrogen fuel is depleted, helium fuses into carbon, and eventually, heavier elements like neon and iron are formed. This progression marks a star's final stages, as the lack of energy output causes gravity to take over, pushing the star toward an inevitable collapse. The supernova countdown. Stars evolve dramatically throughout their lifetimes, shifting from the fiery blue hues of youth to the deep red tones of maturity. Historically, Betelgeuse has captured human imagination. In the 2nd century BCE, Chinese astronomers recorded its yellowish hue, while later observations by Greek and Roman astronomers, such as Ptolemy, described its orange appearance. This distinct coloration has intrigued observers for millennia. In recent years, Betelgeuse has displayed unexpected behavior. In 2019, it dimmed suddenly, baffling researchers. Initially, they theorized that a massive dust storm originating from the star's surface had obscured it. However, the source of the dimming remains unclear, with some suggesting a large planetary object might have disrupted its surface or even been consumed by the star. Adding to the mystery, Betelgeuse has nearly doubled in brightness recently, an unusual phenomenon for an aging star. This erratic luminosity is not entirely unprecedented, as variable stars like Betelgeuse periodically expand and contract, altering their brightness. Nevertheless, this increase in brilliance defies typical stellar aging patterns, leaving scientists puzzled. Signs of imminent transformation. Betelgeuse's dimming and brightening cycles hint at dramatic changes within its core. Observations reveal that the star is ejecting vast amounts of material into space, creating a cosmic dust cloud of immense proportions. This veil has significantly darkened Betelgeuse, reducing its rank among the brightest stars in the night sky. Once among the top 10, it now struggles to remain in the top 20. Recent studies suggest that Betelgeuse may be in the final stages of carbon burning, a precursor to its inevitable supernova explosion. If so, this event could happen much sooner than previously estimated. While prior projections placed the supernova thousands of years in the future, some researchers now propose that it may have already occurred, with its light still traveling toward Earth. Implications of a supernova. The last recorded supernova in our galaxy, the Kepler supernova, occurred centuries ago. Betelgeuse, in its advanced evolutionary stage, is a prime candidate for the next visible supernova in the Milky Way. This would be a dazzling celestial event, temporarily outshining the Moon and casting shadows on Earth. However, the consequences of such a stellar explosion extend far beyond its beauty. Betelgeuse's supernova could provide invaluable data for astronomers, offering a rare opportunity to study the life cycle of massive stars. Yet, its collapse could also have unpredictable effects on nearby celestial bodies. Fortunately, at 650 light-years away, Betelgeuse poses no direct threat to Earth. However, the vast amounts of energy and radiation released could impact space environments. Observational challenges. Studying Betelgeuse is like piecing together a complex puzzle. Its unpredictable behavior has defied expectations, leaving scientists with conflicting data. Evidence of mass ejections, coupled with its dramatic recovery in brightness, suggests a series of smaller eruptions rather than a single cataclysmic event. Despite advances in technology, observing Betelgeuse remains challenging due to the vast scale of its changes and the distances involved. Decades of research have revealed fluctuations in its brightness, indicating that the star is aging and nearing the end of its life. However, predicting the exact timing of its demise remains elusive. Conclusion. Betelgeuse's mysterious behavior continues to intrigue and mystify astronomers. Whether it is on the brink of a supernova explosion, collapsing inward, or undergoing a series of complex changes, its fate holds profound implications for our understanding of stellar evolution and the universe itself. As we observe this colossal star, we are reminded of the dynamic and ever-changing nature of the cosmos, a spectacle that continues to captivate humanity. The immense mass of a star like Betelgeuse initiates a cascade of events when it approaches the end of its life. This culminates in a tremendous shock wave that travels outward through the star's outer layers. The energy from this shock wave heats the surrounding material, causing it to explode in a brilliant burst of light and energy. The ejection of outer layers. During this process, the star's outer layers are expelled into space, enriching the interstellar medium with heavy elements. These ejected materials play a critical role in the formation of new stars and planetary systems, perpetuating the cycle of cosmic evolution. Betelgeuse's influence on its galactic neighborhood. The supernova explosion of a massive star like Betelgeuse has far-reaching effects on its surrounding environment. The materials expelled during the explosion can spark the formation of new stars and planetary systems. Additionally, the shock waves from the event can trigger the collapse of nearby molecular clouds, leading to the birth of new celestial bodies. The heavy elements produced in Betelgeuse's core and released during the supernova also contribute to the chemical enrichment of the galaxy, which is essential for planet formation and the development of life. Historical and cultural significance. Throughout history, Betelgeuse has been a prominent feature of the night sky, influencing various cultures and astronomical observations. Ancient civilizations noted its distinct color and brightness, often associating it with myths and celestial beliefs. In medieval Europe, its reddish hue and prominence in the constellation Orion made it a significant star in folklore and astrological interpretations. Modern astronomy and Betelgeuse. In recent years, Betelgeuse has become a focal point for modern astronomers due to its unusual behavior and potential for a supernova event. Advances in observational technologies, such as space-based telescopes and high-resolution imaging, allow scientists to study Betelgeuse in unprecedented detail. Methods like photometry, which measures changes in brightness, and spectroscopy, which analyzes the star's composition, provide critical insights into its current state and future evolution. Challenges in predicting supernova events. Determining the exact timing of a supernova is a complex challenge. While scientists estimate the likelihood of such an event based on a star's age and behavior, precise predictions are hindered by numerous variables, including the star's mass, composition, and environment. Current models of stellar evolution and supernova mechanics offer valuable insights, but much remains to be learned about the specific conditions that lead to a supernova. Continued observations of Betelgeuse and other massive stars are essential for refining these models and deepening our understanding of these spectacular cosmic phenomena. Betelgeuse as a case study in stellar evolution. Studying Betelgeuse provides a vital case study in stellar evolution. By examining its behavior and characteristics, scientists gain insights into the life cycles of other massive stars and the processes that lead to supernovae. Betelgeuse's unique properties, such as its size, luminosity, and erratic behavior, offer valuable data for developing and testing theoretical models of stellar evolution. These studies also help astronomers understand the broader context of star formation and galactic evolution, as well as the role supernovae play in shaping the cosmos. Public interest and educational outreach. Betelgeuse's dramatic behavior has captivated the public's imagination, sparking widespread interest in astronomy. Educational programs and popular science articles often highlight Betelgeuse as an example of the fascinating and dynamic processes occurring in the universe. Public engagement with such topics fosters curiosity about science and encourages a deeper appreciation of astronomical phenomena. Future observations and research directions. As technology continues to advance, future observations of Betelgeuse will yield even more detailed insights into its behavior and evolution. New telescopes and observational techniques will enable scientists to monitor the star's activity with greater precision, uncovering additional clues about its eventual supernova. Researchers are also leveraging computational models and simulations to better understand the internal processes of Betelgeuse and other massive stars. These models help predict the star's future behavior and refine our understanding of the mechanisms driving supernovae. Conclusion. The study of Betelgeuse offers a captivating glimpse into the life cycles of massive stars and their impact on the galaxy. From its immense size and intricate fusion processes to its potential as a supernova, Betelgeuse remains a central focus in astronomy. As we continue to observe and analyze this remarkable star, we gain invaluable insights into the dynamic processes shaping the universe and the role of supernovae in galactic evolution. Betelgeuse's eventual explosion will not only mark a dramatic event in the cosmos, but also contribute to the ongoing cycle of star formation and chemical enrichment in our galaxy. A cosmic explosion is a spectacularly brilliant event that occurs when a star meets its end. These explosions are not harmful to life on Earth and can safely be observed with the naked eye from our planet. One such fascinating celestial body is Betelgeuse, a red supergiant in the Orion constellation, which plays a crucial role in cosmic evolution. Studying Betelgeuse helps us understand the life cycle of massive stars and offers insights into the final stages of stellar evolution and the impact of supernovae on the cosmic environment. The role of Betelgeuse in stellar evolution. Betelgeuse, classified as a red supergiant, is in the advanced stages of stellar evolution. Unlike smaller stars, which burn their hydrogen fuel slowly and evolve into red giants, massive stars like Betelgeuse exhaust their nuclear fuel at an accelerated pace. This rapid consumption causes the star's outer layers to expand dramatically, leading to its transformation into a supergiant. At its core, Betelgeuse contains helium and heavier elements such as carbon and oxygen. As the hydrogen in its core depletes, fusion reactions shift to the outer layers, causing further expansion. This phase is governed by a complex balance between gravitational forces and radiation pressure, ultimately pushing the star into its supergiant phase. The core fusion process. The energy and radiance of Betelgeuse are driven by nuclear fusion within its core. Initially, hydrogen fuses into helium in a series of reactions that release immense energy. Once the hydrogen is depleted, the core contracts under gravity, increasing temperature and pressure. This triggers helium fusion, producing heavier elements like carbon and oxygen. During this stage, the outer layers of the star expand significantly, giving it its massive size and distinct red hue. In massive stars like Betelgeuse, fusion becomes increasingly complex due to their high mass. The core undergoes multiple stages of fusion, forming concentric shells where different elements are fused. Each stage alters the core's composition and energy output, leading to the star's dynamic behavior and eventual instability. The supernova mechanism. When Betelgeuse exhausts its nuclear fuel, it will no longer generate enough energy to counteract the gravitational pull of its own mass. This results in a dramatic core collapse, triggering a supernova explosion. The supernova process unfolds in a series of rapid events. Core collapse. Without sufficient pressure from fusion reactions, the core collapses under its own gravity. This happens at an extraordinary speed, compressing the core into an extremely dense neutron star or, in some cases, a black hole. Explosion. The sudden core collapse releases an immense amount of energy, propelling the star's outer layers into space in a massive explosion. This marks the star's end while enriching the cosmic environment with heavier elements essential for the formation of new stars and planets. Betelgeuse's eventual explosion will offer a rare opportunity to witness the dramatic finale of a massive star's life cycle, shedding light on the complex processes that shape the cosmos.